Hi, welcome to an Arduino tutorial from Robojax. My name is Ahmad Shamshiri. In this video we're going to control a servo motor using a potentiometer and display the angle on the LCD1602. Also for the LCD2004, which has 20 characters and 4 lines, which has only 4 wires. You can get the code for this project by clicking at the link below the video in the description, which will take you to robojax.com/learn/Arduino. Let's get started with this. In my all videos, under the video in the description, click show more and you can click on any of these links to jump directly to different section of the video. This is a detailed video where people will learn. If you don't want to learn and just grab the code and run it, the link for the code is below the video in the description. I've seen a lot of requests to display the angle of the servo motor on the LCD. In this tutorial, I'm going to show you how to connect servo motor, how to connect LCD and potentiometer with Arduino, so you can display the angle here. And because this needs 5 volts, this needs 5 volts, and potentiometer also can work with 5 volts for this purpose. So I have to use this breadboard. So breadboard is supplying 5 volts for all these 3, so we need it. I'm gonna also show you, if you don't want to use it, servo motor must be connected to VCC, but because this needs around 20 milliampere current and this needs very little, about 1 milliampere, for these we can use a digital pin, and I will show you the code so you can eliminate this breadboard if you want. For this code you can use either the 1602 or 2004. This one we have I2C module soldered, so you just need 4 wires. We will use a servo motor. The servo motor is a type of motor that can rotate only 180 degrees. So it doesn't go 360, and we can set the angle, whichever angle between 0 to 180 we want. And it has 3 wires. The middle wire is 5 volts. We will connect it to 5 volts. And then the darker wire, sometimes it might be black, it will be connected to the ground. And then the lighter wire, sometimes it is white, and now it is orange. This is the signal, where the signal goes to control pulse width modulation enters here. It will be determined. So these 2 will be connected to 5 volts, and then we will connect this to pin 3. And we need a potentiometer. The potentiometer has 3 wires. This is actually a variable resistor that when you rotate it, the value of the variable resistor changes, and we will connect one side to 5 volts, one side to ground, and then when we move it, the voltage will go from 5 to 0, and we will read it through this pin. We will connect it. I have a separate video explaining this. The link for the variable resistor or potentiometer will be below the video in the description. I have a separate video introduction to this and testing it. The link for that is also below the video in the description. I have a separate video for the LCD and also for setting the address for this. The link for this is below the video in the description. So these 3 will have separate independent videos. In this video we are just going to control the motor and display the angle here. This potentiometer can be between 10 to 100 kilo ohm, even 500 kilo ohm will be fine, because the lower value will consume a lot of current, so make sure to get higher values, so in case if you are powering this up with battery, so it will last longer and it consumes or wastes less energy. And also I'm going to show you with this LCD2004, which has 20 characters and 4 lines. So the same code will work with both of these displays, 1602 and 2004. Let me now explain the wiring. First, we are going to create a 5 volt source. As you can see, this is the red is connected to 5 volts, the brown is connected to ground, and I've connected it to these points on a breadboard. Doesn't matter if you have this type of breadboard or this, it's exactly the same. So these lines are exactly those lines. So we have 5 volts, this red All of these pins are now 5 volts up to here, and all of these are ground. If you want more 5 volts, just put small jumper up to here, and this will be also 5 volts. For this servo motor, the 2 pin that is red and brown, we will connect it exactly the same way as they are here, red and brown. So the 5 volts goes to the servo motor from here and the ground. And then for the LCD, I'm going to connect this ground to the ground and VCC to 5 volts. So these 2 pins, I use the same color. This is coming from Arduino to this point, and these 2 wires are going to servo, these 2 are going to the LCD. The right one will go to 5 volts. I'm going to connect it to 5 volts. And the last pin will connect it to the ground. Make sure that the middle pin is not connected to the ground or power supply. And the middle wire from potentiometer will be connected to analog 0, where we will read the voltage. For the servo, the yellow wire, which is the signal wire for the servo motor, will be connected to pin 3. And we can connect it only to pin 3, pin 5, 6, 9, 10, 11, because they have tilde, this line. And as you can see also, they have been labeled in here. So these pins are capable of pulse width modulation. Otherwise, you will not get pulse width modulation and the servo will not move. For the LCD, this SDA and SCL will be connected accordingly. SDA will be connected to analog 4, SCA will be connected to analog 5. If you're using other devices, for example Uno Ethernet, SDA is A4, A5 is SCL, Arduino Mega, 20 is SDA, and 21 is SCL, and the Northern Duo, they have been all mentioned. I will provide you the link for this as well. And if you're powering your servo motor, LCD and potentiometer from Arduino digital pins and VCC, here is how you do it. For your servo motor, this pin is not changing, that's just these 2 pins, connect and 5 volts. So this is how you connect. The servo motor must be connected to this 5 volts because you cannot power it because this needs more current than these pins can supply. And then for the LCD, I have defined pin 13. So the VCC and ground will be connected, VCC will be connected to pin 13, and the ground can be connected in here because we have ground and here. So 13 have been defined. For the potentiometer, connect the right pin to pin 12 because we have defined this pin as VCC for potentiometer in the code. The left pin connected to ground, we have extra ground here, second ground, and the middle pin is connected to analog 0. To get the I2C address for your module, I will provide you this I2C scanner. I've taken it from this address. Just copy and paste it. Do not worry how it works, and upload it. You can see now it is working, but I'm going to show you if the wiring, everything is correct. Once you upload it, to open the serial monitor, we just click on this right side on the magnifier, or go to Tools, Serial Monitor, or press Ctrl, Shift and M to open the serial monitor. It will print the I2C address like this, and every few seconds it reads it and prints it. If you are unable to read this text, then on the right side on the lower corner here, it must be set to 9600. Once you got the address, close it. Now it's time to hit the subscribe button so you get updates of my upcoming videos. Now let me explain the code. The first thing that you need is to download this LCD Crystal I2C. I will provide you the zip file, save it. After that, click on Sketch, include library, add .zip library, and then point it to where you have saved it. For example, if this was inside download, tutorial, and this was your zip, just select it and click open. Once you're done, then it will be included and we can continue with this. Wire.h is not required, it's part of Arduino IDE, part of this software. Then we will type the I2C address for our LCD. This is number of characters. Our LCD has 16 characters if you count them, and then we have 1 row, 2 rows. So this 16 refers to the number of characters, 2 means number of lines, and this is the text that is displayed in here. So you can put it in your language or any other language that you have, or whatever you want to put. And then we are passing 1, 2, 3 parameters here, the address, the number of characters, and the line to this object that we create from the instance of the class. Then servo.h is also part of Arduino IDE. When you have this software, you have it, you don't download anything. In this line, we define our object servo from this instance of the servo class. So anyway, this is defining an object for one servo, and if you have servo 2, just copy this line and make it servo 2 or 3, whatever you have. And then pot 1 pin, this is potentiometer 1 pin, analog 0. You can change this accordingly if you want to connect it to the other pin. And here, this is a servo pin where we connect the pin, and make sure that the pin that you're connecting has this tilde, which means it is pulse width modulation enabled, otherwise it will not work. And here on the Arduino website, they mentioned for Arduino Uno, Nano, and Mini, these are the pulse width modulation pins. For Mega, these are the pins, and for Leonardo and the rest are listed here. I will provide you the link to have a look at this. Then we set for our servo, we set minimum angle. Usually the servo will go from 0 to 180, but you can change it if you want to limit the servo not to go to 180, let's say from 20 to 100, whatever you want, but between these two maximum value, minimum and maximum, you will set it. Once you set the value, the servo will not go beyond the value that you set here. And here, these two lines are used inside the code, servo value and then angle 1. So this is for the servo, do not change them. Inside the setup, we define the serial monitor with 9600 baud, and this is the baud rate. If I click on the right side or click on tool, serial monitor, or press Ctrl Shift M. When I click it, if you go to the right and on this point, you will see that this is the 9600, and it will show you the angle. So this shows the text at the beginning with this, and then we do my servo 1 attach. We are attaching servo pin 3 in this example to the servo, so that pin is being controlled by the servo. Then this is for LCD. We use LCD.begin to initialize the LCD, and we turn on the backlight, and then we print this text on the LCD, and that is the text that you see here. Then we set the cursor to character 0, line 1, and it means go to, this is line 0, that's line 1, character 0, 1, 2, 3, and so forth. So we come to line 1, character 0, and then we print the word angle. This is being printed with a space, and then we wait for 2 seconds for this to be initialized and the user can read it. And after that, inside the loop, this code from here to here, everything we have will run continuously with a delay of 20 milliseconds in between. So first we use analog read pot pin, it goes to the analog 0 pin and reads the value, and then we will store it here. We call it servo 1 value, which have been defined at the top of the code. Then we pass this value to this function called send servo. So this comes here and goes to this function, which I'm going to explain it. So let's go to send servo, and here is send servo. The value that comes here, we call it value, and type is integer, and here we define a new integer called new angle 1. So we get the value, which is from 0 to 1023. That is 2 to the power 10, it's 1024, but because we have 0, it will be subtracted by 1. So this value is between 0 to 1023, and we want to map it between the servo angle minimum, which is 0, to servo angle maximum, which is 180, or whatever value you set. So this map is calculating and accordingly converting the value. When it is 0, it will be minimum. When it is 1023, it will be maximum. So the result of this calculation will be stored in a variable called new angle 1, and here we check if angle that was initially saved at the top, which is 0 or whatever, is not equal to the new angle that we have from potentiometer, then we update it. The reason I use this is to avoid also rewriting this portion. So everything on the screen does not change from the beginning to end. We just change this portion and clear from here to here. All this portion, we clear it and rewrite it. If the value changes, as you can see, it's not changing. But if I change it, you will see this portion blinks and it changes. So if the value is new, then we say my servo 1, write new angle, this new angle 1, sends the servo to that angle. So the servo moves, then we also send the value new angle 1 to the LCD display, which is a function at the bottom. And at this point, we will also have the angle 1, which was the old value. We set it to the new angle. So this is being stored in this variable. So later on, we can again compare it. If any change happen, we will update it. And then we have 100 millisecond delay in between, so the servo can move. Now let's see when we send the value of angle to this LCD display, what happens. It comes here. The value will be called angle here. So this value, we first clear the characters, which means that we are clearing from here everything. So this will eliminate the flickering of the screen, and I'm going to explain it. And then we print also this angle with a little space, and then the actual angle is being printed here. This ln mean go to the new line, which means the text is printed, the angle is printed after that, and then we have a new line. And after this, we set the cursor at LCD, set the cursor, we get the length of the text, because everybody will have in different languages. Angle is now, for example, 1, 2, 3, 4, 5 character with this colon, and this will be 7. In some other language, it might be longer. So we will make sure that to get the length of this, and this text will be just after the text that you have. So if your text, the word angle is up to here, then 130 will be displayed at the end. So this is very nice. Automatically will take care of the length of the text. And then we print, we say lcd.print, it prints the angle, which is this 130 here on the screen. And then we LCD print character 223. This is printing this angle symbol at the top. Now clear characters is a function that I've written it here. This goes from the length of the text to the maximum length of the display. If you're using 2004, which is long, so it will be accordingly calculating, going to the end, clear it from here up to the end, even if it's 20 characters like this, or if it is 16, it will be cleared. So this function, the I is changing, and it sets the cursor to that character of the line 1, and it writes 254. 254 means clear, like this. So it clears it completely and makes it ready to be written next. And that's the complete explanation of the code. And here's a demonstration where I've taken 5 volts from Arduino to this point, and from here I've distributed to this potentiometer or variable resistor, and also I've powered up the servo and also powered up the LCD. All of these are connected to this point, which are being connected to 5 volts. So this is much stable because we have exactly 5 volts from the power supply. And this is now 0. As you can see, now it goes 179 and responds very well. And here's a demonstration with the LCD1602 which has 20 characters and 4 lines. So the code and everything is the same, except in the code you have to mention number of characters if you want to use it. But even if you don't change the code, the setting will work because we will not have more characters here to fit. So the code for this and this will be the same. The only thing is that you have to set the I2C address. Here is a demonstration of powering all these 3 from digital pins without breadboard. In this case, because this needs very little current, it has been connected to one of the digital pin. The potentiometer have been connected to the digital pin. Only servo motor have been connected to this 5 volts. And it is now on the left side. As you can see, it shows 0. And it shows maximum 173, and that is due to the voltage that is coming from the output of the pen, the digital pen. So it's not fully 5 volts, it's a little less than 5, so that's why we don't get 180. We can compensate that in the code, and we can add some value in terms of angle. So it responds very well, as you can see. And here let's change the minimum angle to 50 and the maximum to 140. Now the code has been uploaded. Now if I rotate this to the minimum, it shows minimum 50 because we have set it in the code. And if I rotate this fully, and if I rotate this now fully, it goes to 139. That's 139 and 40. That's due to the variation in this potentiometer or just the voltage. But it goes between 50 to 140. So this way we can limit it in the code as well. The code is very customizable. Thank you for watching an Arduino tutorial from Robojax. If you learned something and found this useful, please thumb up, as this will help my video in the search algorithm of YouTube. If you have comment or question, please post it at the comment section below. I try to answer and reply. And don't forget to subscribe so you get updates of my upcoming videos. If you have comment or question, post it at the comment section below. I try to answer and reply. If you want to get updates of my upcoming videos, make sure to subscribe. Both rotate together and being controlled with the same potentiometer. Using these 2 buttons of left and right. So when you press the right, it goes with 10 degrees to the right, and you press it left, it goes to the left. So, or just if you want to use just one button, you hold it, it goes to the left and right, and until wherever you stop, it stops. To control 16 servo individually, I'm going to show you how to control individually few of them, and then I'm going to show you how to control all 16 of them with the same or different angle.